we're Group 6 and we'll be presenting our project Smart Dustbin with IoT notifications. My name is Suhas and I will be talking about the project objectives, functionality, and design. So we want for the design project we want to develop and build an automated sensor-based dustbin to eliminate physical touch, and it's also like we also want to implement the Internet of Things. So we have like an IoT based alert messaging system to keep the user informed as to like when the dustbin is full or like when the dustbin opens and closes. One of our main motivations for us to develop this is the increasing amount of garbage which is being dumped every day in the urban environment. We want to some find a way to help solve this problem and help the municipalities of that localities um, find a better way to uh, take out the garbage and know when the garbage is full so we can prevent overflowing of waste. Moving on to functionality, I'll walk through the basic functionalities of our project and of our smart dustbin, and my other teammates will get more into detail on those topics. Um, so we using the help of ultrasonic sensors, the smart dustbin is able to detect when a person is nearby. So if, for example, I walk in front of the smart dustbin, and the ultrasonic sensors detect that I'm there, detect my presence, and using servo motors, we're able to the dustbin is able to open the lid and close the lid. So as if I once I walk towards the dustbin, the lid opens. I can throw my waste and garbage inside, and once I walk away, the lid closes. The dustbin also has uses the LoRa module to establish a wireless communication with a computer terminal, with which it communicates with messages and alerts. For example, if the dustbin is full and is about to overflow, it sends out an alert to the computer terminal saying that uh, the garbage and waste needs to be taken out, and yeah, so we can help prevent overflowing that way. This depending on the user of the smart dustbin, it can have a lot of uh, pros. Like, for example, if this is a dustbin in like a municipality dustbin, then the municipality of that locality will know that that particular dustbin is about to be full, and they can send out the necessary people to come take out the trash. The dustbin also has a display, a TFT display device, which basically shows the current capacity status of the dustbin. So people who use the dustbin don't throw in too much waste and cause an overflow of garbage. So for example, if there's like 80% left, 80% of the dustbin is full, and there's like 20% left, people will not throw in too much waste inside. Yeah, so all of these functionalities will be discussed further in detail by my other teammates. All right, moving on.
Now coming to the hardware and software architecture of our design, as you can see to the right side of the slide, we have a partially completed design halfway through the semester, and in the coming weeks we intend to complete it, of course, as a simulation on Tinkercad, and as a team we also have plans in order to make an actual working prototype should things go well. Now, the project consists of essentially has four hardware modules in it, and I will briefly explain how they're interfaced with the microcontroller as well as how they communicate with one another. And of course, the program, the written in C language, which controls the Arduino board. So first, I will go through the flowchart of the program so as to give you an idea of what the smart dustbin essentially has to do. And the program is broken down into four main parts. One is the main process, of course, which handles the decision making and control of the lid, which decides whether the lid should be open or closed based on the dust, whether the dustbin is full and when someone approaches it. And the sub processes that are involved in the program. One is object detection and level sensing, which is done by the ultrasonic sensors. The second one is the status indication, which essentially displays whether the dustbin is in use or it's full and needs to be cleared. And finally, we need to make a decision of when the trash is clear to reset and start the whole process again when the dustbin can be used again. Now coming to the hardware components. So firstly, we have the ultrasonic sensor. Now this ultrasonic sensor is the HC SR04 module, which is a 4-pin module and has, of course, power and ground and trigger and echo pins, which uses high frequency signals so that they cannot be heard by humans. And this calculates the distance, and the range we have set for this is between 0 and 2 meters. So anything above that is out of its range. Now when someone comes close to the dustbin, it detects the object, and when it's closer than 1 meter, essentially meaning that someone wants to throw trash into the bin, it triggers a PWM signal, which essentially turns the servo motor, which I'll explain later, and opens the dustbin. Now another sensor of this is used for level sensing, and this is mounted inside the dustbin, and it's at the top corner of the dustbin, so that when the trash is full and something is detected, it triggers this, the LoRa module to send a signal to the, the PC terminal in order for the trash to be collected. Now coming to the servo motor, we have a very lightweight, high torque servo motor which weighs roughly just about 9 grams and can turn a whole 180 degrees, which is sufficient for us. And this gives a very high torque of almost 2.5 kilos per centimeter, which is sufficient to open the lid of any dustbin irrespective of how heavy it is. And this is triggered by a PWM signal, which gets triggered based on the ultrasonic sensor when the dustbin is not full and someone approaches it. Now the third module we have is the LoRa module, which is used for communication between the dustbin and the PC terminal. Now we use the LoRa module, of course, because it's a low power with a high range, and when the dustbin is completely filled and needs to be cleared, the LoRa module sends a signal to the PC terminal for the trash to be collected and be emptied so that it can be used.
Hello, I'm Lloyd Lobo, the third member of Group 6, and I will be completing this presentation by telling you about the thin film transistor display, some of the milestones we have achieved, our Tinkercad simulations, the schedule we'll be following in the future, and how we will test our project. So firstly, the thin film transistor display uses pixels with coordinates to display color instead of using the traditional line by line text display format. It also uses a serial peripheral interface with serial communication, which is a serial communication between the Arduino and itself to send data across. We will also be using the Adafruit GFX library to display shapes and text easily and efficiently. So we will be using this TFT display to display the dustbin status at all times and the percentage of how much it is filled. Additionally, if the dustbin is full, it will display the time since it has been full, as well as the ID number of the dustbin, so as to serve as a record of which dustbin is being overflowed and for how long, to better manage waste disposal. So now I'll move on to some of the milestones we have achieved recently. Firstly, our project topic finalization was a big milestone, of big first step, where we decided to go ahead with this project based on its how we would implement it and what modules we would use. Apart from that, we completed our project flowchart about how the system would run and how the project would go on. The block diagram was then completed, as well as the operating principles of the modules. And on Tinkercad, the assembly of the system was completed. Uh, of course, since Tinkercad does not have some of the modules, such as the LoRa module and the TFT display, we made the connections for just for the servo motor with its ultrasonic sensors. And as you can see, the two blue modules at the top right are the ultrasonic sensors. The Arduino is the big blue block at the bottom, and the servo motor is the s- is the smaller blue block on the left. And you can see the connections have been made successfully, and the servo motor is also connected to a power supply, um, because sometimes the servo motor requires enough power to move the dustbin lid. So this is our assembly, and we will soon begin writing the code for these specific modules. So this is our schedule, tentatively, which we will be trying our best to follow to complete our project efficiently and on time. So in from week 7 to 9, that is from now until week 9, we plan on working on the coding aspects, the software parts of our project, with coding our modules for the ultrasonic sensors, the servo motor, the LoRa module, and the TFT display. In week 10 and 11, we plan on doing simulation runs on Tinkercad, and then um, looking at what bugs exist in our code as well as our simulation. We will plan on fixing them in week 12, as well as starting our final project reports and project presentation in week 12, and moving on to week 13. That will efficiently finish our project within the deadline, and uh, efficiently, basically. So here is how we will test our modules. As you know, all modules are subject to manufacturing defects, and if found, we should immediately uh, replace these modules. But since most of our work will be on Tinkercad as a simulation, we don't have to worry about this physical attribute. So our ultrasonic modules will be on Tinkercad, can be tested just by placing a reflection point, depending on how far we will require the person to be from the dustbin for the dustbin to open, as well as how far down the trash has to be detected for it to be considered as a full dustbin, as well as to display certain percentages of how much the dustbin is full. We will just need to set a reflection point on Tinkercad, which is relatively easy. To test the servo motor, we will need to simulate motion based on the state of the dustbin, whether it's to be open or to be closed. The servo motor will send pulses and will thus move. The LoRa module will also send informations from the Arduino to PCs, uh, to store the data and to store what state the dustbin is in. The TFT display also will display this data um, through the Arduino, of course, and um, the main data that it will display, as mentioned before, is the states of the dustbin, as well as the duration the dustbin has been full and the ID number of the dustbin. To conclude, we will further work on work division of the module coding, and hopefully uh, all teammates will participate equally, which I'm sure it will happen, as well as we will try to efficiently use Tinkercad for our simulation of our project. Due to the unfortunate circumstances of the coronavirus, we hope to use this simulation software to the best of its ability. And this dustbin that this smart dustbin that we will be implementing with IoT notifications, we hope to implement this not only in homes but also offices for efficient waste disposal, and uh, for envisioning a better